air quality meet the national standard. Then we have a 5 days, 6 days forecasting. Then we said before the game, API will be 65 to 75. And during the game, opening ceremony, API will be 85 to 95. So after we look at this forecast system, we say we're getting it very easy. So we have to do something to assure the air quality better. But in worst case,
while we're Is everyone here? We set up a temporary lab here last weekend, not super stable. We asked for a maximum weight limit of 10 people on top, not more than 10 enough right now. We have an automated weather station here, and then beyond it, you can check out a view right now from any of you is an Aeronet sun photometer, which does automated measurement of AOD, signal scattering, LV here. Over there, you see the inlet for, behind the cameraman, you see the inlet for a black carbon instrument, which is sitting down vertically below. Two instruments. One is a TSI Best Track DRX. It measures PM1, PM2.5, and PM10 simultaneously. And then the next box over is an instrument that measures particle size distribution. So it can give you the number of particles for different size categories from 0.5 micrometers up to 10 micrometers. Down below, the thing with the two wheels, that's the black carbon instrument. Once we go in groups, I will explain more about how it works. Next to it is a carbon monoxide instrument compared to one. We kind of have to take turns going around a bit. One group and the rest of you look around a little bit. But not more than 10 people in top at once. Tomorrow, we only have a limited time now. Tomorrow then, we'll actually be broken up into little groups and we'll be working with individual instruments yourself. Learning how to calibrate the carbon monoxide instrument. So, can I ask, so this is here is the black carbon pumps air down in the previous ground from the inlet through a filter gate, and it measures the change from the combination of change in transmission and change in scattering off the tape. It can calculate from the rate of change. It can calculate the black carbon concentration going through. For the concentration, of course, it needs a very accurate measure of the airflow through, which is both the pump volume but also information about pressure and temperature. Measurements and things very carefully. This instrument here is a carbon monoxide instrument. Still needs to be calibrated, so the number is showing of negative values, of course, you cannot trust. We moved it here from a different altitude and we need to calibrate it, and I will do that tomorrow. It measures carbon monoxide by looking at how much infrared radiation gets reduced because of absorption by carbon monoxide and that. Over on the NO2 converter, the ozone instrument looks at absorption of ultraviolet by ozone in the sample air flowing through. And the nitric oxide instrument actually does what it does. It looks at the reaction of NO with ozone and the rate of change in.
So it's a chemiluminescent instrument?
It's not. It's actually a different QBTech instrument. What it does is it looks at the rate of change in ozone by when it's a calibrated ozone source reacts with the NO from air. Chemoluminescent instrument would be much bigger and not. I don't know of any portable one that runs on 12 volt DC. We were trying to
But
do mobile.
UV photometric is more accurate. UV photometry.
I think I'm not 100% sure. I'll get back to you about that.
Okay.
And then for measuring NOx or NO2, we have next to it is a NO2 to NO converter, which uses a catalyst, and there's a valve that switches back and forth between measuring NO coming directly from the air and NO plus.
Like a thermometer.
It's like an nephelometer with a nephelometer built in.
Also not nephelometer.
It has both elements of both built in. Yeah. I will tomorrow. Let me double check. Okay. Bit more than a liter. I have in here a carbon monoxide instrument, a black carbon instrument. Tape that goes through, it's like an old cassette player at the bottom. It measures the rate of change in light passing through the tape. The more black carbon you accumulate on the tape, the more it absorbs the light and less light goes through. So you can relate the absorption of light passing through the tape to the amount of black carbon, or the rate of change in light. We're getting a concentration of black carbon. Right now about 8 micrograms per cubic meter or so, and it stores the data internally like that. And so what the instrument also has is several angles of light meters that look at the scattering of the light back at different angles. The instrument over here, the blue box, is the carbon monoxide.
Is it a wavelength dependent or what is your wavelength?
Looking at the absorption of infrared by carbon monoxide in the sample cell in a fixed length. This little cylinder here is a measurement of the volume of air being pumped through. And so we both need to have the airflow calibrated very well, and for that we have a flow meter here. The instrument as well, at the top you'll see, will have a temperature sensor, because you need to, and then there's pressure sensors as well, because you need to have a very accurate measure of pressure and temperature as well. Because the next couple of students to come in. You see here what looks like a very old cassette tape. What it is, it's a filter tape that's slowly through a filter tape. Okay. And any aerosols in the air get accumulated on the transmission decreases how much black carbon is accumulating. Except, of course, you're not only accumulating black carbon, you're also accumulating other, but also at various different angles above it. It has light detectors that measure the scattering back from the tape as aerosols accumulate. So the actual black carbon is.
Particle matter PM important PM1.
Why we need to measure temperature and humidity inside? Any guesses? To have your measurement sensor directly exposed to the sun to shade, and there's actually a fan down here that blows air through it at a constant rate so that it's well ventilated in the shadow. This, of course, is measuring wind speed and wind direction. And then there's a pressure sensor inside. There's solar radiation sensors up here. You can take a look when you come up. And over here we're measuring rainfall. can I have some guesses about how to measure the rate of rain? The area is at the top. What is the problem with that approach? It's more of it's just a cone with a little hole at the bottom. And so the water coming through here, this is called a tipping bucket rain gauge. What does, the water goes into one of these little containers here. As soon as it fills, it tips over. And then the water goes in here. When it fills, it tips over. So the harder it rains, most automated weather stations use either this approach or there are drops hitting. You can calculate the rain rate, but those are the two most common approaches. The data gets collected in here, and a lot of weather stations have a data logger attached right to them. This particular one has a little antenna here. And so you see the current wind speed, wind directions, temperature, etc. there while they're overnight. For the rest of the instruments, so this instrument here, the TSI Dust Track, it measures the mass concentration of it just pulls in air through here and then runs it through the instrument past the laser beam, and looking at if it's raining, you don't want the rainwater to be sucked into the instrument. Particle size distribution over several different. Can you see the digital display, or maybe I should? Okay, yeah, the data. To choose. Right. Temperature probe that I was mentioning about is sitting in here. This here is the inlet for the CO instrument. It's a little filter tape holder. Detector here. Yes, it swings around and turns and points at the sun or different angles to measure both the direct solar radiation and changes in it because of aerosols and the diffuse. We were hoping to get it working properly this morning, but with automated systems it usually takes more effort to get it working. Hopefully by tomorrow. With the rainwater.